In this video, we're going to recap the process of electrolysis. We're going to show how we can represent half equations, and then write half equations for some given electrolysis reactions. We're going to start by recapping the process of electrolysis. So if we remember, electrolysis is where we decompose an ionic compound using electricity. In electrolysis, we have two electrodes, a positive and a negative, and you need to know what these are called. To remember what they're called, we use panic, which stands for positive anode, negative is cathode. So we know that this electrode here is the anode, and this one here is the cathode. Our ionic compound is made of a metal and a non-metal, and the metal will always be positive and the non-metal negative. Because opposite charges attract, this means the metal will go to the cathode, the negative electrode, and the non-metal will go to the anode, the positive electrode. This is a quick overview of electrolysis. You can watch the full lesson video on this if you want to recap it in more detail. We also need to recap what a redox reaction is, and this is where both reduction and oxidation happen. Now you need to remember what reduction and oxidation are, and we use oil rig to do that. Oil rig stands for oxidation is loss of electrons and reduction is gain. So at the cathode, which is the negative electrode, that's where your positive ions are going to go to. It's where your metals will go to. Because the ions which go to the cathode are positive, they're going to gain electrons, so they no longer have their positive charge. Therefore, if they're gaining electrons, we can say that they've been reduced. At the anode, which is the positive electrode, that's where the negative ions, or the non-metals, will go to. At the anode, the negative ions will lose some of their electrons, therefore we can say they've been oxidized. We're now going to look at a visual representation of this. So we can see here how we have got a negative electrode, the cathode, and we've got one of our metal ions. And we know because opposite charges attract, the metal ion will go towards the negative electrode. At the negative electrode, the metal ion will gain an electron and therefore will produce the metal. We can see how the metal, once it has gained the electron, no longer has its positive charge. This time we've got our non-metal, which is negative, being attracted to the positive electrode. At the positive electrode, the non-metal will lose some of its electrons, therefore forming the non-metal, and you can now see that it's gone from having a negative charge, but because it's lost its negative electrons, they've gone to the electrode, it now doesn't have a charge overall. We're now going to look at how we could write a half equation to show what's happening in this reduction process. Now a half equation is part of a whole equation. What a half equation does is it shows you the ions and the electrons. So a half equation shows whether you're gaining electrons or losing electrons. So for example, let's say our metal is magnesium 2+, and we're turning it into magnesium. The first thing we need to do is work out what the overall charge is on each side of the equation. So on the left hand side, the magnesium is a 2+ charge, so overall there are 2 positives on the left hand side. The magnesium on the right hand side doesn't have a charge, so overall the charge is 0 on the right hand side. Now, to make this into a half equation, we need to add electrons to whichever side has the most positive charge. So we can represent electrons in the equation as this, E-. Now, electrons have a negative charge. When we're writing this half equation, we need the total charge on each side of the equation to be the same. So adding electrons will reduce the positive charge, it'll make things more negative, so we need to add electrons to whichever side is most positive. This means we're going to have to add electrons to the left-hand side of this equation. if we have a look at how the charge has changed, it's gone from positive 2 to 0. Therefore, it's gone down by 2. This means we're going to need to add 2 electrons. So the charge has changed by 2, so we're adding 2 electrons. So this would be our half equation. We've gone from magnesium 2+, we've added 2 electrons to it. So if the electrons are on the left-hand side of the arrow, that means we're adding the electrons to something, and then we form magnesium on the right-hand side. So we can double check we've got the answer right by having a look at the total charges on each side. So on the left-hand side, we've got a 2 positive charge from magnesium. The electron has a negative charge, and there are 2 of these electrons, so we've got 2 sets of 1 minus charges. Well, positive 2 minus 1 equals 0. We've got a 0 charge on the right-hand side because magnesium doesn't have a charge. Therefore, we've written a half equation. So let's look at a different worked example. The question asks us to write the half equation for the reaction of aluminium 3+ at the cathode. The first thing we're going to do is write out our aluminium 3+, and we know that the product formed at the electrode will just be aluminium metal by itself. We know it's not going to have a charge, so we can add that onto the equation. So we've now got something on both sides, but we now need to turn it into a half equation. So the first step is working out the charge on each side. So we can see that aluminium had a 3+ charge, so it's got a positive 3 charge on the left-hand side. Aluminium on the right doesn't have a charge, so the charge is 0 on the right-hand side. We now need to work out how many that charge has changed by. Okay, so the charge has gone down by 3, so we know we must need to add 3 electrons to it. Now remember, electrons have a negative charge, so we always have to add the electrons to whichever side is the most positive. In this case, the 3+ charge on the left-hand side is more positive than the 0 on the right, so we're going to need to add 3 electrons to the left-hand side of the equation. So this is our completed half equation. We can check we've got it correct by working out the total charge on each side. So here we can see that aluminium had a 3+ charge, the electron had a -1 charge, but we've got 3 of those, plus 3, -1, -1, -1 equals 0. On the right-hand side, the total charge is 0, so we've written a correct half equation. We're now going to look at how to write half equations for oxidation reactions. So in this case, when the non-metal is losing an electron. We're going to look at the example of chloride ion forming chlorine gas. Like before, the first thing we need to do is work out the total charge on each side. But before we do that, we've got to make sure our equation is balanced. If we have a look at the equation, we've got 1 chlorine on the left, but we've got 2 chlorines on the right. So in order to balance it, we need to make sure we've got another chlorine on the left. In a question, you'd be expected to know that chlorine will form Cl2. You can remember which elements have a 2 after them by using the phrase, "I have no clever or brilliant friends." So if you remember that phrase, "I have no clever or brilliant friends," these are all the elements which go around in pairs. So you need to remember for your exam that iodine goes around in pairs. There's 2 of them, I2. Hydrogen does, nitrogen does, as does chlorine, oxygen, bromine, and fluorine. So we expected for any of these equations to write them as, say for example, N2O2. So Cl- is going to form Cl2. We've now written the balanced equation. There are 2 chlorines on the left and 2 chlorines on the right. What we need to do now is work out the total charge on each side. Chlorine has a -1 charge. There are 2 of them, so in total that's -2 for the left-hand side. Chlorine on the right-hand side doesn't have a charge, so the overall charge is 0. The charge has changed by +2. We've gone up by 2. That means when it comes to adding the electrons, we'll need to add 2 electrons in total. Just like the example we looked at a moment ago, we need to add the electrons to the side with the most positive charge. So in this case, 0 is more positive than -2, so we're going to add the electrons to the right-hand side of this equation. And this is because chlorine is losing electrons. Chlorine is being oxidized. If you lose electrons, they're always written on the right-hand side of the equation. So here we can see the overall half equation when I've added the electrons onto the right-hand side. We can make sure we've got this question correct by checking the charges. So on the left-hand side, chlorine has a -1 charge, and there are 2 of them, for a total of -2. On the right-hand side, this chlorine doesn't have a charge, so it's 0. The electron has a -1 charge, and there are 2 of them. So each side has got a charge of -2, therefore we've written the half equation correctly. Let's look at a worked example, writing the half equation for the reaction of oxygen at the anode. The first thing we need to do is write the equation for this. Now, if you remember the phrase, I have no clever or brilliant friends, there's an O in there, which means we must make O2. It will go around in pairs. So we can see here that we need to know the product of the reaction is O2, and again, that's because oxygen is one of the elements which goes around in pairs. Now we've written that equation, we need to balance it to make sure we've got the same number of oxygens on each side. This is the balanced equation. We started off with 1 oxygen on the left-hand side and 2 on the right. So we've had to add a big number 2 here, so we can now see that we've got 2 oxygens on the left-hand side and 2 oxygens on the right-hand side. We then work out the total charge on each side. So on the left-hand side, oxygen has got a 2- charge. There are 2 of them, so the overall charge is -4. On the right-hand side, the oxygen doesn't have a charge, so the overall charge is 0. We can see that that charge is changed by +4, which means whenever we add the electrons, we're going to need to add 4 of them. Remembering that we always add the electrons to the side which is most positive. 0 is more positive than -4, therefore we're going to need to add 4 electrons to the right-hand side of this equation. Giving us a final equation of 2O2- goes to O2 plus 4E-. If you double check the charges, you'll see oxygen is -2. There are 2 of them to give us -4. The electrons have a -1 charge, and there are 4 of them, giving us -4 on the right-hand side as well. Therefore, we've written a complete, balanced half equation. Now we need to look at how you'd write the half equations if we have an aqueous solution. Remember earlier on in this topic, we looked at if you've got an aqueous electrolyte, you've got a choice of products you can make at the anode and the cathode. So at the anode, if your non-metal is in group 7, then that's the non-metal you're going to produce at the electrode. If your non-metal is not in group 7, you're going to make oxygen and water instead. So we now need to look at how you could change the OH- ion, which again is present at the anode in an aqueous solution, how we can change that into oxygen and water. If you're unsure on what products we form and why in aqueous solutions, watch the previous video on electrolysis again for some more worked examples. So we're going to start off by writing the equation. We know that at the anode, in an aqueous solution, we're going to have OH- ions, and we know that's going to form O2 and H2O. The next step is to balance the equation. We've got 1 oxygen and 1 hydrogen on the left-hand side, and we've got 3 oxygens and 2 hydrogens on the right-hand side. So we can balance this equation as follows. Now we have 4 oxygens and 4 hydrogens on the left-hand side, and 4 hydrogens and 4 oxygens on the right-hand side. So our equation is balanced. We now need to look at the total charge on each side. So we can see that the total charge on the left-hand side is -4, because this OH ion has got a minus charge, and there are 4 of them. There are no charges on the right-hand side, so the overall charge on the right-hand side is 0. Therefore, we're going from -4 to 0, which is a change of +4. And this is the final equation. You can see that we've added 4 electrons to the right-hand side. This is because the charge changed by 4, from -4 to +4, so we needed to add 4. We always add the electrons onto the side which is the most positive. 0 is more positive than -4, so the electrons went on the right-hand side. At the cathode, which is a negative electrode, the most reactive out of the metal ions or the hydrogen ions will stay dissolved in solution. Whichever is the least reactive will be produced. Therefore, if the metal is most reactive, we'll make hydrogen gas. If hydrogen is the most reactive, we'll make the metal. We've already looked at how to write half equations for metals. We're now going to look at how we can write the half equation for hydrogen. So we'll start off going from H plus to H2. Again, remembering I have no clever or brilliant friends. The H represents hydrogen, so we know it's H2. The next step is to balance it like we've done before. So we've got 1 hydrogen on the left, and we've got 2 on the right. So we've now written the balanced equation. We now need to work out what the charge of each side is. So the left-hand side has a total charge of 2 positive. The right-hand side has a charge of 0. Therefore, we're going to need to add 2 electrons to the most positive side, which will be the left. And you can now see the fully balanced equation. 2H plus 2 electrons go to H2. The total charge on each side is now 0. We're now going to look through a worked example of this entire process. We need to write the half equations for the electrolysis of sodium chloride. We're going to start off by looking at the metal, sodium, and the non-metal, chlorine, separately. Sodium is a metal, which is positive, so this reaction is taking place at the cathode, which is negative. We know at the negative electrode, we've got the sodium ion and the hydrogen ion. We know the most reactive stays in solution, and the least reactive is made. By comparing the reactivities, we can see that sodium is more reactive than hydrogen. Therefore, the sodium stays in the solution because it's the most reactive, and the hydrogen will be made. The next step is to write out our equation. So we know we're going from H plus ions to H2. We then balance the equation, so there are 2 H's on each side. And finally, we add the electrons. Now, we've looked at this example in more detail earlier in the video, so rewind it if you're not sure how we get from the start to the end. And this is a reduction process because we've gained electrons. The electrons on the left-hand side of the equation, therefore we've gained them. For the chlorine ion, it's a non-metal, which is negative, so this process will take place at the anode. We know that at the anode, we've got the chloride ion and the OH ion. We know that if it's in group 7, we make it, and if it's not in group 7, we make oxygen and water instead. Chlorine is in group 7, you can use your periodic table to check that. Therefore, we're going to make Cl2 at the electrode. We then write our equation, remembering that we produce Cl2, remembering I have no clever or brilliant friends. We then balance the equation, so we have the same number of chlorines on each side. And finally, we add the electrons. Again, we've looked at how to do this process earlier in the video, so feel free to rewind it if you need to recap how we get from the start to the end. And finally, this is an oxidation process because we have lost electrons. The electrons are on the right-hand side, so that means they've been lost. So let's look at one more worked example. This time, we're writing the half equations for electrolysis of copper sulfate. The first step is we look at each half separately, the metal half and the non-metal half. The copper is the metal, so this happens at the cathode. We then compare the reactivities, so what is more reactive, the copper or the hydrogen? Well, as we can see, the hydrogen is more reactive than the copper, therefore the hydrogen stays in solution, and we're going to produce the copper. We then write the equation out. Note that you won't be expected to know that copper forms an ion with a 2+ charge. That will be given to you in the exam. You'll be expected to know that group 1 metals have a 1+ charge and group 2 metals have a 2+ charge, but if the metal isn't in group 1 or group 2, you'll be told what charge it has. We've got the same number of coppers on each side, so we don't need to balance it. We can go straight into adding the electrons, like we've already talked through how to do in this video. And therefore this is a reduction process because the copper has gained electrons. The sulfate ion is the non-metal, so this is going to happen at the anode. And again, if the non-metal is in group 7, we produce the group 7 element. If it's not, we make oxygen and water instead. The sulfate is not a group 7 element, it's got sulfur and oxygen in, they're both in group 6. Therefore we're going to produce oxygen and water at this electrode. We write out the equation for the hydroxide ions forming oxygen and water. We then balance it, so we've got the same number of each element on each side. And finally we add the electrons like we did earlier on in the video. This is therefore an oxidation process because we've lost electrons, they're on the right hand side of the equation.